Picture this: AI agents that talk to each other as easily as your browser talks to a website. That's not some distant future. It's happening right now. Two protocols, MCP and A2A, are building the foundation for how agents will work together. And in the next 12 minutes, I'm going to show you exactly why this matters and how it changes everything. Here's the problem we are trying to solve. On the left, what we want, which is agents that collaborate on their own, agents that handle complex multi-step problems, agents that can grab whatever tools or data they need. And on the right, what we actually have today, every vendor and company with their own agentic format. Custom integrations everywhere, each one built from scratch. And agents that can't even find each other, let alone work together. Think about it like the early 2000s before USB. Every device had its own cable, nothing was compatible, you needed a drawer full of adapters just to get through the day. That's where AI agents are right now. Now, before we go further, let's get clear on what we mean by agent so that we are on the same page. An agent is not just a chatbot with a few plugins bolted on. It's a full system with 5 pieces. Number 1, a foundation model. That's the brain, the reasoning engine. Number 2, memory, both short-term, like remembering what you just said, and long-term, like context from previous conversations. Number 3, planning, the ability to break big tasks into smaller steps. Number 4, tools, ways to reach out and do things in the world. Call an API, query a database, send an email. And finally, number 5, which is the agent actually interacting with the environment based on what it figures out. Once you have multiple agents with these capabilities, the need for a standard way to communicate becomes obvious. Because without standards, every pair of agents needs its own custom connection. And that's an n-squared problem. Unsurprisingly, it doesn't scale. So let's map out the landscape of protocols. There are 2 useful ways to think about this. First, object orientation. Context-oriented protocols handle how agents interact with their environment, the tools, the data, the memory. MCP, which stands for Model Context Protocol, lives here. Inter-agent protocols govern how agents talk to each other. That's where A2A or agent-to-agent protocol sits. Second, application scenario. General purpose protocols work across any domain. MCP and A2A are both general purpose. Domain-specific ones like LMOS or agents.json solve narrow problems in specific industries. For systems that need to scale, the 2 that matter are MCP and A2A. Everything else is either merged into these or serving a niche use case. Let's dive into MCP first. MCP stands for Model Context Protocol. It standardizes how agents access and use external tools and data. Think of it as the bridge between your agent and everything it needs to do its job. Here's the simplest way to understand it. Before MCP, every integration was one-off. That means custom code for every tool, every API, every data source. But with MCP, you build the connector once and every agent can use it. It's a clean client-server model. The agent is the client, tools, APIs, databases, those are the servers. An MCP server can expose 4 types of things. Tools are model controlled, which means the model decides or LLM decides when to call which tool. Think functions, APIs, services. Those are tools. Second, resources. These are application control. And these are files, knowledge base, or static data that you need access to. Prompts. These are user control. And this is templates, workflows, pre-built instructions that the server offers the user and they can then choose which prompt to use for their use case. And finally, sampling, which is server control. This is where the server can delegate a call back to the language model if needed. The key insight here is MCP separates what something does from who controls it. And that's what makes it composable. MCP uses JSON RPC under the hood. That's just a standard way to send requests and get responses. But it supports 3 transport options, depending on where your agent and tools live. Number 1, STDIO for local communication, which means the agent and the server are on the same machine. Use this for things like file system access. Number 2, HTTP with server-sent events for remote communication. Here, the server pushes updates to the clients over the web. Use this for cloud services and APIs. And finally, streamable HTTP, which is the latest addition to the spec. It starts simple and upgrades to streaming when needed. Pick the one that fits your architecture. And here's the full picture. On the left, the client. That's your agent application. It initiates requests, processes responses, manages the session. In the middle, JSON RPC 2.0. Clean, simple protocol. On the right, the MCP server. It exposes tools, resources, prompts, and sampling. Below that, you have security, OAuth, JOT, TLS, all of the standard web security practices. And finally, at the bottom, the transport layer, which is HTTP with server-sent events, streamable HTTP, and STDIO. Layered, everything modular. So that's MCP. It solves the agent-to-tool communication. Now, let's talk about A2A. A2A stands for Agent-to-Agent Protocol. It standardizes how agents collaborate and communicate with each other. If MCP is USB, A2A is email for agents. A2A is to AI agents what SMTP is to email clients. It lets any compliant agent discover and talk to any other compliant agent. No custom bridges, no vendor lock-in. You write to the protocol and it just works. A2A has 4 key primitives. Agent cards. Think LinkedIn profiles for agents. Identity, capabilities, endpoints, permissions. The unit of work. Every task has a unique ID and a defined lifecycle. Messages. Single conversational turns with clear roles like user, agent, or system. And finally, artifacts like documents, data, results. These are the tangible things that the remote agent produces and returns to the client agent. Together, these enable networks of specialized agents to collaborate through a common language. Here's how it works in practice. User sends a prompt to the client agent. Client agent discovers available remote agents using agent cards, creates a task with a unique ID, sends messages with content and roles. Remote agent processes the message, manages task state, and creates a response. That response might include artifacts, the actual work product. And the remote agent can push notifications back to the client when something changes. It's clean, stateful, composable. Okay, enough theory. Let's make this concrete with a real use case. Recruitment automation. Perfect example because the workflow naturally breaks into specialized tasks. You've got a screening agent that parses CVs and checks qualifications. A scheduling agent that coordinates calendars between candidates and interviewers. An interview prep agent that tailors questions based on the candidate's background. And a feedback agent that collects structured feedback from interviewers after the interview. Each of these is a natural candidate for a separate agent. Now, let's look at 3 ways to architect this. Scenario 1. MCP only. One big orchestrator agent connects to all the tools through MCP, like resume parser, calendar API, question generator, email service, all MCP tools. What are the pros? Simple to set up, centralized control, and standard tool access, using the MCP protocol, of course. What are the cons? Single point of failure. There is no specialization, and this will lead to scaling bottleneck in the future. It works, but it's monolithic, and monolithic doesn't necessarily scale. Scenario 2. A2A only. 4 specialized agents. They communicate through A2A, task delegation, agent cards, the whole thing. What are the pros? Specialized agents, distributed workload, standard agent communication. Cons? Custom tool integrations for each agent, fragmented connections, potential maintenance nightmare. The agents can talk to each other, but they can't share tools. So you're rebuilding integrations over and over. Scenario 3. MCP plus A2A. Agents collaborate through A2A. Agents access shared tools through MCP. The top layer is A2A protocol for agent collaboration, which includes tasks, artifacts, agent cards. The bottom layer is MCP protocol for standardized tools, which includes resume parser, calendar, API, question generator, email service. Each agent only accesses the tools it needs, no duplication. The benefits of MCP plus A2A approach: distributed intelligence, standardized tools, enterprise ready. The agents talk to each other using a standard protocol. They access the tools using another standard protocol. This is the sweet spot. This is the pattern that scales. Okay, let's tackle the objections, because engineers should be skeptical of new standards. First objection: security vulnerabilities. Open protocols expose vulnerabilities. That's fair. But here's the thing. Open standards get reviewed publicly. That means faster fixes. Proprietary solutions, on the other hand, hide flaws until someone actually exploits them. Community security audits make protocols stronger, not weaker. You want 1,000 eyes on your security model, not 5. Second objection: too complex. Too difficult to deploy without specialized expertise. Let me explain the maths here. Say you have 5 agents and 10 different tools. Without a standard, you need a custom integration for every combination. That's 5 times 10. 50 integrations to build and maintain. Now add one more agent, you need 10 more integrations. Add one more tool, you need 5 more. So this grows fast. This is the n-squared problem. With MCP, you build each tool integration once. 5 agents, 10 tools, but only 10 MCP servers. You go from 50 custom integrations to 10 standard ones. That's the difference. And SDKs exist now. Even the documentation is better. And once you've built it and deployed it, everyone benefits. Third objection: the return on investment is unclear. Hard to justify investment without clear metrics. Think about maintenance. One standard integration versus dozens of custom ones. Think about speed. When you want to add a new capability, you plug in one MCP server and every agent gets access. First movers get competitive advantage. That's the ROI. Fourth objection: standards usually fail. Most new standards fail to gain traction. Fair point. But look at the backing. Anthropic built MCP. Google and the Linux Foundation are behind A2A. MCP already has a thriving ecosystem just months after launch. And remember, even protocols like HTTP back in the day faced this kind of skepticism. USB faced this skepticism. JSON faced it as well. The ones that solve real problems and have institutional backing tend to win. Finally, here's the big picture. MCP standardizes context, which is how agents access tools and data. A2A standardizes collaboration, which is how agents work together, and together they enable scalable, interoperable agent ecosystems. The future isn't one giant agent doing everything, it's networks of specialized agents working together through open protocol. If you're building agent systems, start exploring these protocols now. Check whether your platform supports MCP and A2A, and if they don't, you are in a walled garden. In the description below, I've linked tutorials from Hugging Face, Microsoft, and Google to get you started. Thanks for watching. I'd love to hear how you're thinking about standardization in your own systems. Drop a comment below And if you want more deep dives like this, hit subscribe. See you in the next one.